Hello everybody, this is Sam from HiPy. Today we're going to be looking at regression and statistics regression, how to use statistical regression, what it's used for, in general, how we have a good time with it, and we'll just look at some general fun time with statistical regression, I guess, why not? The modules that we're going to need for this is scipy.stats. Probably sick and tired of this one by now. Scipy.stats as stats. We're also going to need pandas. Pandas as PD, and we are going to need matplotlib. Import matplotlib.pyplot as plt, and then we will shift enter to execute this. And we are going to be looking at, in this video, we're going to be looking at some very simple regression. In the written resource, we look at some more complex regression with stats models, but as I've said before, I don't really want to go through that because that's going to take a very long time, and we don't have a lot of time in these videos because I want to keep them interesting and keep them a little bit fast-paced. So we're going to start by just importing some data that we have. The data is going to be called regression.csv, or let me check what it's actually called. Regression.csv, there we go. pd.read_csv, and then it's regression.csv, there we go. And then we can look at the actual data. That's probably really bad to do. Let's look at the header of the data instead of doing that, because otherwise we're just going to get a million bit of data. I'm being a bit naughty here and just not printing anything and just outputting it to the console, but hey, what can you do? Gives us a nicer formatting. So a bit lazy, but it's probably a nice way to do things for the most part. And we're just going to be looking at the test we're going to be doing here is our data correlated? So we're going to say, does this Y data depend on our X data? And the kind of very rule of thumb or very quick and dirty way of doing this is by just scattering the data and plotting it on our scatter plot. So we have here X data and test data Y data. This is a little bit abstract, but it's a good example of what's going on. Because this X data and Y data could be at anything, but for now we're just going to call it X data and Y data, and we're going to show. We can see here, yeah, it does look like there's some kind of correlation between the two. Obviously, that's not good enough. We can't just say, well, maybe. We want to be doing some kind of statistical test here. We want to be being a little bit more rigorous with our statistics. So what we can do, the linear regression function from scipy.stats, really good, very easy to use. We just go print stats dot. Have I done this as X and Y? That's weird. Stats dot lin regress. Let me spell that right. Res, and then we will use X data and Y data. So test data. X data, Y data, X data, and test data, Y data. So let me do this. Boop and boop. And then shift enter here, we will get the results of what's going on here. So we can see that we have a slope of 6.2, which means that's the slope of what's going on here. The intercept, which tells us the point at which it intercepts the y-axis. So these are two values which we can use to create a model. So we will look at that in a minute after this. We also have an R value, and the R value tells us, or is an indication of how useful our model is. So it tells us how kind of correlated it is. And then our P value tells us how likely it is for there to be some kind of correlation between the two. So here we can see 1.7 times 10 to the power of minus 15. That's easily below 5%. That's very, very strong evidence that our data are correlated. And we also have the standard error here, which is something that can just be useful later on down the line. If you're interested in statistics, it can be quite useful. So we are then going to look at how to use matplotlib to talk about kind of what's going. Well, we can look at it to be a little bit more visual with our learning. So the first thing I'm going to do is we're going to change this a little bit. We can see here that we actually get a tuple out. We get the slope intercept, R value, P value, standard error. So what I'm going to do is I'm just going to copy and paste this it's just to save me from typing. We are just unpacking this tuple into its kind of elements. We have the slope, intercept, r-value, p-value, standard error, and then we are going to be creating a model and then plotting this in matplotlib so we can see what's going on behind the scenes. So we're going to go xfit is equal to np.linspace 5 to 65, because that's kind of what our data is distributed between, and we're going to be doing 101, so it's nice and evenly distributed. The yfit is going to be the slope multiplied by our xfit, and then add our intercept. So what this is doing is it's taking every single x value, it's timesing it by 6.2, and then adding 43.15 to it, which means that we're going to get a nice little linear line, which we expect our data to be correlated by. So then we are going to use our matplotlib knowledge to create a figure. Then we're going to create an axis on that figure. Fig.add _ axes, and then we list the start and end points. Then we are going to plot a we're going to plot our line, so yfit, and then we're going to plot this as a red, and then we are also going to scatter our data as before. We have I'm just going to copy and paste this in because it's a little bit easier, and then we are going to show the plot. And then I have done this wrong because there's an equal sign here, and I've done this wrong as well because we don't have np, so we actually need to import numpy. Import numpy as np, and then we have linspace, and slope is not defined. That's because we haven't actually run this cell yet. There we go. After 5 or 6 errors, we actually get what you want. Python's quite helpful in giving us good error kind of interpretations, which is better than certain languages I've worked with. But it was quite easy to work through the errors there. It was a couple of silly mistakes of sloppiness from me in general. So sorry about that. But we can see here what we actually get at the end is a very nice line that we can see is gives us a very rough correlation of what's going on for our data. So we will see that we have this, which is a very simple example. In the written resource, we also have multiple regression. So we have multiple different kind of dependent or independent, I can't remember which one it is, but we have multiple different kind of things which influence another thing. Instead of just one thing which influences another thing. So that's kind of nice and interesting to look at. I recommend you look at that. We also look at the stats models kind of outputs, and then we look at how to interpret them. In the mini project, I just have some more x and y values for you. It's quite abstract again, but it's just to practice this stuff, just to make sure you're comfortable with it, and looking at the x and y kind of values of that. So I will see you next time. This is it for the stats at the moment. There might be some more videos added on depending on how much we work with, but those will be at a later date. So I hope you've had fun in this video. I hope it's been interesting and you've learned something, and I will see you next time.